So now we've talked about many different climate types and classifications via the Koppen classification system. Now we can talk about how those climate types might change or be changing, and we can look at several models for that type of statement. And not everything is cut and dry. So we can look at one well-known model called the Palmer Drought Severity Index. And this can look back at both temperature and precipitation, which is what we have been looking at, temperature and precipitation, for consequences like crop survival and water supply consequences. And we can compare something like the Dust Bowl of the 1930s to this, what was termed severe drought in 2015 that led to so many devastating California wildfires. And you can see that when we look at the Drought Severity Index for August 1934, and we are looking at average temperature and precipitation versus actual temperature and precipitation for consequences, you can see that August of 1934 was just devastating throughout the country. In severe drought, I would say 50% of the country, 45% of the country. Really amazing to see that. And you can see why so many people drove along Route 66 to get out to California. Now you might say, well, California is not in a really great situation either because they are in severe drought. But if you think about it, and you probably read The Grapes of Wrath in high school, The Grapes of Wrath was set up in this area, which was not experiencing a drought. So people went there to try to get jobs to pick grapes and pick other crops that were relatively unaffected by drought. This was devastating during the Depression. Now, in this section for March of 2015, California is under extreme drought, and that did lead to the fires. The rest of the country was not as affected. So something to think about there. And in terms of that, you can look at, in 2015, we can look at El Nino for some of those issues that happened at that time. And let me go on to the next one. Another way to look at climate changes is to go to the USDA plant hardiness zone maps. But the USDA will tell you, do not look at these maps for climate change. And I can explain to you why they are really not suitable to look for climate change, although you'll find plenty of people who do. The map at the top is a map that was used based on 1960s plant hardiness data. And that data is only taken from temperature, and it's only taken from the coldest night of the year. So it's a very limited data set for these areas. When I was growing up, this was the plant hardiness data that was on the back of every seed packet. And I was in 4-H, and I showed my cucumbers and my Swiss chard at the county fairs. So I paid attention to these hardiness zone maps. And these maps are not put out often. I was using the 1960 map through 1980. And then this map came out in 2012, but the data is from 1976 to 2005. So it's a 30-year data, but it comes out 5 years later. So there's some lag on it. The other point is you can't use this for climate change because the USDA is constantly updating their methods. So their methods are changing between these two maps, and it's kind of like comparing apples to oranges, especially for something as potentially important as climate change. And I wanted to show you another device that is put out for temperature data, and that's the NOAA climate related as opposed to plant related from the USDA, The NOAA is climate-related hardiness zone maps. They use 11 zones, and they also go with an average annual minimum temperature, not exactly the coldest night of the year. And they use apples to apples methods because they are still using the methods that they used back in 1971, which may not be the best thing, but they haven't changed their methods, so you can see more of a change over time. Interesting to think about, because you can see these maps are put out more frequently. They're put out every 10 years. So you can see here 1971 to 2000, and then 1981 to 2010. And look, you're starting to see the creep of the northern sectors just slightly, especially when you see the coldest sectors retreat in this map. And that becomes important because this area right in here, and I'm going to move myself out so you can see exactly, this area right in here in Montana is home of Glacier National Park. I've actually been out there to see the glaciers, and that cold area is receding. So catch them while you can. The glaciers are receding fast at Glacier National Park. You can also see that the cool areas of Michigan are receding in the later 2010 data, as well as the warmer areas are moving into northern Texas. So NOAA has a different take on it, but NOAA is still only using temperature data. They are not using precipitation data, so that it's not a complete picture when we look at that. Now, on the other hand, there's another device for you to look at, and you can look at the Koppen Geiger climate classification projected into the future. So that this is Europe from 2000 to 2099, and their projection of North America from 2000 to 2099. You can see the Arctic areas retreating. Now, the problem here is that, and I'll pull myself over so you can see better, the problem here is that they only have 10 years of data, less than that, between 2000 and their submission of their prediction at 2010. So figure they have about 8 years of data in here, and they're making projections for a century. So now you have a better understanding of the scientific method and how to look at data and how to see the pros and cons of what you're looking at for data. I will try to run this one more time for you so you can take a look at it. There's Europe again. You get a better feel for the tundra receding in blue. And when you go to North America and you see Iceland as well, you can see the tundra and the ice caps receding as well. Now, in summation, I wanted you to know that Chapter 12 is important because it gives us the baseline of climate. And you should know that tropical climates are areas where the months are all warm and the precipitation can be intense. Sometimes the precipitation is continuously intense. Sometimes it definitely has a seasonality to it with a monsoon. And for dry climates, they're generally at 30 degrees latitude, for what we know, and they're marked by sinking air and compressional warming. That's where you find your arid deserts and your arid steppes. In the middle latitudes, like the roaring 40s, like we talked about, anything goes. And there are distinct winter and summer seasons, which we are noticing in New Jersey. So I hope that this gives you a good baseline. Subsequent chapters will look at how we measure climate change and what we're seeing. See you on the other side.